because I know yesterday we did a good job trying to kind of squeeze in Tuesday's lesson on a Wednesday schedule, and we got through labeling the unit circle of what I wanted us to, but we didn't get to then taking the sine and the cosine of the angles and using the unit circle as much, okay? So I'm going to show you an example before I get to these, because there's only a couple on this that are straightforward and the other ones are a little bit more challenging. So I'm going to kind of make up one more just for us to kind of walk through together first. If I want to find the cosine of 3 pi over 4, what I'm asking you for is a specific trig function, cosine, of a specific angle, 3 pi over 4. And we learned yesterday from setting up some right triangles in our quadrants that cosine, to jog your memory, was always equal to x because it's the adjacent over the hypotenuse, and that was x over 1, which was x. Okay? So cosine is always equal to x. So when you see something like this, we're kind of translating it in our head to what is the x coordinate at the angle 3 pi over 4. Okay? So then everyone right now point at 3 pi over 4 on your unit circle. From all the things you filled out yesterday, find where 3 pi over 4 would be located. It's in quadrant 2 as a hint. Find 3 pi over 4. And then you want literally the x coordinate at that angle, which, raise your hand if you can tell me what the x coordinate is at 3 pi over 4. Jason?
Oh, square root.
Perfect, like that. Okay? So that's what I'm looking for when I'm asking these problems, and then some of these are going to get slightly more challenging, okay? So using that, was anyone able to find sine of 3 pi over 2, or really quickly you can look. Anyone, any takers for sine of 3 pi over 2, and you can look at mine too. So find 3 pi over 2, and then I want sine. Sine is not x, sine is what? The y coordinate. So what is the y coordinate at 3 pi over 2, Leo? Negative 1 is correct. Notice at 3 pi over 2, the y coordinate is negative 1. Okay? So sine and cosine are just looking at the coordinates at the correct angle and then finding it. Okay? Now, some of these then get a little more challenging. For example, this next one, it's not sine or cosine. Now we've got cosecant. But does anyone have an idea of what I can do when I have cosecant? I'll go with the one I have from me at Adrian.
I was thinking, because cosecant is the opposite of sine, we could like find what the sine is and just do the opposite of what it is.
Okay, great. And by opposite, we're talking reciprocal. And so I'm going to take the sine of 3 pi over 4. I'm not doing the reciprocal of the angle. Notice sine and cosecant, theta stays the same, right? So I'm not flipping that one. I've got 3 pi over 4. So everyone find 3 pi over 4. Find 3 pi over 4 again. We already pointed at it earlier. Sine is our y. So you'll notice that y at 3 pi over 4 is root 2 over 2. And then let's use Adrian's suggestion and just find the opposite or the reciprocal. So flip it and you have 2 over root 2. Is that my final answer?
No.
I like that. Keep
No.
that. Why not? Shocking. What? Yes. I don't want to have a square root on the bottom. We want to leave our final answers. We're going to rationalize the denominator. Remember, send it to the top. So multiply times root 2 over root 2.
Man.
And you'll have 2 root 2 over, when I multiply these two together, I end up with just 2, because the square roots will cancel. And then these two cancel, which is nice. So all you'll end up with when you can finish simplifying is root 2. Okay? So that's another example where we have a reciprocal function. Another thing that you might run into, I'm just going to do these 3 across the top, is you might have an angle. We didn't get to any of these yesterday. You might have an angle like this, 11 pi over 2, and if you go to use the strategy I just shared with you, where you're looking on your unit circle for that angle, what do you notice? It's not there. I heard someone say it's not there.
Go Justin.
There's Justin. It's not there. So 11 pi over 2 is not on there. However, we learned about these things called coterminal angles, which means that angles can share a terminal side or be in the same location, but they can look like different measures. Does anyone remember how I can go back and forth between different coterminal angles? I'm going to be adding and subtracting something, and I should end up in the same place. Chime? Good. Remember? Okay, picture, this is a circle. I am standing on the circle right here. Picture me. I'm on the circle. And if I add or I walk in a full 360 degrees, I'm going to end up in the same spot, right? And so if I add to like 15 degrees, 360, that big angle is in the same place, right? And then a good thing he pointed out is that if I'm in radians, a full circle is not 360, it's 2 pi. So if I'm in radians, I would want to add or subtract a full 2 pi, and I'm going to have an angle that like looks more simple but is in the same spot. Okay? So what I'm going to do when I see something like this, I'm going to take 11 pi over 2, and I'm just going to do one extra step before I look at my unit circle. I want to, in this case, what do you think, add 2 pi or take away 2 pi? I heard someone say, louder.
Take away.
Take it away, because I want it to get smaller. That looks too big, because the biggest pi over 2 I got is 3 pi over 2, right? Okay, so let's take away a circle, which would be 2 pi. Because these are fractions, I need it to be over 2, right? I want to have the same thing on the bottom. So I can multiply this times 2 on the top and bottom. What's 2 times 2? And I have 4 pi multiplied times 2 on the bottom, and I've got 2. That's the same thing as 2 pi, right? 4 pi over 2? Check it, simplify it, it's the same thing. Okay. 11 minus 4 would be?
8.
7.
Happens to me all the time.
I forgot.
You're good. I forgot what 11 minus 4 was.
Oh, no.
I forget all the time too. So we get, no, you're good. We get 7 pi, oh no, yeah, 7 pi over 2. Is that one on our unit circle? Oh no, it's still too big. But let's look at me on the circle. If I take away a full circle, I'm in the same spot. If I take away another full circle, will I still be in the same spot? Just keep going until you get one that you like. So we're going to take away again 4 pi over 2. And now what's 7 minus 4? 3 pi over 2. Okay? So literally, we learned this, and this is good to study for your quiz because you will be asked about coterminal angles. We know that 11 pi over 2, 7 pi over 2, and 3 pi over 2 are a full circle away from each other, so they're all coterminal. They're in the same location, they have the same terminal side and the same initial side, right? Okay, which means instead of finding cosine of 11 pi over 2, let's find cosine of 3 pi over 2, and we should get the same thing. So find 3 pi over 2, and then we'll wait till I have a lot of hands. Everyone raise your hand when you see what cosine or the x value at 3 pi over 2 is. I got 1, 2, 3, 4, 5 people that have found it. I need some more, because if your hand's down, it makes me think, like, I don't know where it is, I don't know how to find this, so I need some feedback from y'all. I only got about 5 hands. Everyone's looking at 3 pi over 2. We've got to make sure you got it for tomorrow. Find the x. Diamond, what did you find? What's x down there at 3 pi over 2? 0. Okay? Happy?
Yes.
So that's a quick summary of kind of some of the things we didn't get through. How to find sine and cosine, how to find any reciprocal function, flip it, and how to find it even if the angle is bigger than 360 or less than 0. If it's negative, you can add or subtract 2 pi or add or subtract 360. Okay? Okay, so today, same thing all over again, and more of practice with like things like this do first. Except we're going to add in the last few things we haven't filled in on the unit circle, and you will have a beautiful completed unit circle by the time you walk out of here. Okay, so just as a few reminders, your problem set is due on Monday. However, your quiz is to, oh, by the way, sine gerene over cosine gerene is equal to?
Tangerine.
Get it? Sine is y, cosine is x, and yesterday we learned tangent is equal to y over x, tangerine, sine gerene, cosine gerene.
That was creative.
Pretty fun.
That was creative.
I saw mine laughing. Someone was laughing. Okay, but anyway, so your problem set is due on Monday. However, you have a quiz tomorrow. Your first quiz of Unit 4. And remember, I gave you that freebie problem set, which meant you might not have gotten as much practice with some of those first few things we learned in the unit, like coterminal angles and reference angles and solving right triangles and all of that stuff. So I would, if you still have that blank copy, like pull it out and maybe just pick a few random problems to make sure when you look at them you know what to do. And if not, that means look over those things in your notes so that you have it for tomorrow, okay? What you can use for tomorrow. I will not be here tomorrow. You'll have a sub, which I mentioned yesterday. So your sub already knows that y'all can use, I'm going to let y'all use this for tomorrow because I don't expect you to have all of it in your brain memorized for tomorrow. I'm going to talk about how we're going to get there for like the unit exam, but for now, please bring this because they know you can use this. However, I've told them that you cannot like share these. So like you forget yours, Josh and Maritza can't like pass it back and forth throughout the quiz. So you have to have your own or you're just on your own with that. You also need to bring your calculator because the sub knows that you can use your calculator for the last 2 problems and they're going to be monitoring that, okay? So calculator, last 2 problems because that's going to be some solving triangles like we did before Thanksgiving. And then bring your yellow unit circle so you'll have that for any problems like this, okay? And then we're going to build to the memorizing. Okay, other quick thing about reminders. Really quick, grab your problem set because there's a little mistake I need to fix. Sometimes my Word documents go crazy.
For the unit circle, do you want us to fill that thing out, like the whole thing?
We're to the rest of today, that's what we're going to be doing.
Who found the mistake you did?
You know what?
Did you find the mistake?
Sorry, I forgot. No, Ehong found it. Good old Ehong. Okay. So it's not really a mistake, it's just like there's not a question. If you solve this, then you probably should have run into a problem. So one thing that you could have to do tomorrow that we've learned that we did as a do first yesterday is I could give you one trig function and you have to set up a triangle with your adjacent, your opposite, your hypotenuse, and you have to give me another trig function. And you have to figure out what quadrant it's in to get your positives and negatives, right? Okay, so for this one, I gave you tan, I asked you to find cosine. For number 6, I give you sine, I don't ask the question. So, you need to find, my bad, tangent. Go ahead and add that, because there's not a question.
Yep.
For that one, I want you to find tangent of theta. Okay? Alright, that's all we got with that. Okay. So, I just mentioned that for the quiz tomorrow, you can use this yellow sheet of paper, which is great news. Because right now, all I'm focusing on is that we can recognize that cosine is x, that sine is y, that cosecant is the reciprocal of sine. All of those things you're already having to deal with in your head. That in one night I don't expect you to all of a sudden have mastered all of this as well, okay? So you're using this tomorrow just like we used it in our do first. However, the goal is going to be either through writing the patterns and like figuring it out as you go. We need to become more automatic to where if I say sine of 135 without looking at this paper, you could figure it out or know where 135 is and know what the point is because of the stuff that we've been doing yesterday and today. Okay, so here's how we're going to get there in terms of making this more of an automatic skill, kind of like our multiplication facts or something like that to save us some time on quizzes and tests. What we're going to do is I'm going to kind of roll this out to you one quadrant at a time. So starting on Monday, I'm going to give you a little half sheet. I'm showing you the quiz right now. It looks like this. It's a blank unit circle. And you guys have to fill out for me the angles in degrees, the angles in radians, and the points for quadrant 1 only. Okay? So this weekend you're familiarizing yourself with quadrant 1 and the triangles that we looked at for 45. Today we're going to do 30 and 60, and then 0 degrees and 90 degrees. Okay? On Tuesday, we're going to roll out then, see if you can reflect it into quadrant 2, and you're going to have to write down for me all quadrant 1 and quadrant 2. Wednesday, 1, 2, and 3. Thursday, 1, 2, 3, 4, so that we're finally at the point where we have the entire thing, and you can use that because your second quiz is on next Friday, and you will not have this yellow sheet of paper, okay? Friday and the following Monday, I'm going to be offering however many retakes all of you guys need, okay? So for this should really be more than anything an easy quiz grade, because as you progress it does get harder because you're adding more quadrants, but they will FA each other. So all you need is to eventually be able to write all 4 quadrants, and you can get a solid 10 in the grade book, which is a really helpful quiz grade to have. Yep.
It's gonna be a whole quiz grade, like each one is gonna be a whole quiz grade?
Each one's gonna, like they'll FA each other, if that makes sense.
So let's say you get.
We'll talk, I don't want to spend too much class, we can talk more about like the weighting and how that works. Okay. Thanks, Justin. Anyway, so a few tips for this. Use the fact of all the patterns we've learned in the special right triangles to like not memorize it as in straight up just like 135 is this, like understanding 135 is a multiple of 45, and so it's a 45, 45, 90, and we know that that has that root 2 over 2 relationship, right? So using those things to figure out the different angles. A couple tips I did provide on the back of this, blank ones. So for Monday, you can be practicing like covering it up and making sure you can write it 4 times, right? Okay, so try that out. Also, check out on your iPhone, there's lots of apps to help you out. I think I mentioned this yesterday. One of them is called the Unit Circle Quiz, very creative name. So if you search that in your apps, I've used it before and used it for some people last year. Basically it gives you either an angle in radians, an angle in degrees, or a point, and you need to think about where it is on the circle, and click, and it either lights up green or red, and then it gives you a little score at the end. I don't think this one has a setting where you can practice like 1 quadrant at a time, so it'll be more helpful when you get to the end where you need to think of the whole picture rather than just quadrant 1, but you can probably find a bajillion other things that can do exactly what you want it to do. So just ideas, thoughts to consider, okay? All right, very good. So today we get to wrap things up, and we're going to talk about the patterns of 30 degrees and 60 degrees, and walk out of here with a filled out unit circle and some practice finding sine, cosine, etc.
Is the app free?
Yeah, this one is. Yeah, I don't pay for apps.
Oh, it is?
I only get free ones. Yeah, this one's free. That's why I don't know if there's like fancier ones that are like hundreds of dollars that you want to invest in. I'm sure you do. But do it. You'll look really cool. I promise.
Are you sure it is?
It is pretty nice, so I don't know why that's free.
Because you told
I
us
would charge
yesterday,
for
and
it.
so like I checked yesterday, and we had to pay 99 cents.
For the unit circle
Yeah,
quiz?
you told us yesterday, you were like, download an app, so I was like, okay. And I saw the exact one.
They gave it to me for free. I don't know. Let me check after.
Okay.
I'll Google it again. But there's a free one out there. Maybe you got a fancy version. You know how sometimes they have like Unit Circle
'Cause that
Plus,
one's the
and
one.
you can
That
like do
one's the
special
one that
stuff.
popped up. That one's
You know
the
what I
one
mean?
that popped up.
They always have that. Sorry, am I ignoring you, Jason? What did you say?
I just like, that was the first one that popped up. It was like the 5 stars.
It looks like this? Okay, sorry. Okay, let me check it out.
Oh.
If you don't have 99 cents, I'll maybe even give you 99 cents or not. Okay. Part 2 of the unit circle. Here we go. So find this down below the do first. Let's start in quadrant 1 and talk about where in the world our coordinates would come from if we're looking at a 60-degree angle. 60 degrees would be around here, getting closer to 90 degrees. And one way you could think about it is if this is a 180 degrees, it's like we're splitting 180 degrees into 3 pieces, right? 60, 60, 60 would be 180. Okay, so if you think about this in radians, raise your hand if you want to just convert this to radians by multiplying times pi over 180. Anyone want to use that strategy? Multiply times pi over 180? No takers, okay. If you like just thinking about it in terms of a fraction, this is pi, a total of pi. What did I just split pi into? 3 pieces. So it's pi divided by 3. Pi split into 3 pieces. That's the same thing you'll get if you do the conversion. Okay? Alright, so we've got our triangle. Our angle, and we can make this angle into a right triangle so that we can find our x and y, because x will be this distance and y will be this distance, just like we did yesterday with the 45-degree triangle. Okay? So, we don't know this, but there is a side that we do know. Can anyone remind us, same thing as yesterday, which side we know of our triangle? Jeannie? What do we know that the hypotenuse is? Because the unit circle has a radius of 1, and this goes from the middle to the very outside of the circle. So this has a radius of 1. So we have a triangle with a hypotenuse of 1, an angle of 60 degrees, and it's a right triangle, so that's the 90 degrees. Alright, using that, there is a special right triangle that has 60 degrees, 30 degrees, and 90 degrees. And from geometry or your previous courses, you might remember that the relationship between those sides is like I have right up here at the top of the slide. So if this is a certain number, x, the hypotenuse of a 30, 60, 90 is always twice the size of that x side. And this other leg right here is root 3 times the size of that one down there. Okay? So let's use that to try to solve our triangle. If our hypotenuse is 1, and it's twice the size of this one down here, if our hypotenuse is 1 and it's twice the size of this one down here, what's the length of the bottom if this is twice? Jimmy? 0.5, or I'm going to write it as a fraction, is 1/2, right? It's 1/2 or 0.5. So this side has to be 1/2 because this side is 1 and we know it needs to be double, right? Another way to think about it is 1 equals 2x, and so you divide by 2. X is 1/2, right? Okay. This side is always root 3, so if this is 1/2, this is 1, this is always root 3 times my x, so let's just multiply 1/2 times root 3. Think about that as root 3 over 1, multiply the tops, multiply the bottoms. We end up with root 3 on the top, root 3 times 1, and on the bottom, 1 times 2, we end up with 2 on the bottom. Okay? So using that special right triangle, we know the bottom of this triangle is 1/2. This side of the triangle is root 3 over 2. So, coming over to our point, our x coordinate comes from the bottom or the side? The bottom, right? Isn't this traveling side to side? It's how much we went over, right? And so this is going to be since this is 1/2, our x coordinate is going to be 1/2, okay? Our y coordinate comes from how much we go up and down, right? And we went up this length of the triangle, which is √3/2. So that's how we find the y coordinate of that right there. You got this? Okay, cool. So now we're going to take that. I'm going to kind of skip the part in our notes where we roll it out quadrant to quadrant to save some time. I'm going to ask you to grab automatically your yellow unit circle, and let's go ahead and now reflect that into all 4 quadrants and get done with the 60s, and all we'll have left is 30. We're getting close. Okay, so grab your yellow unit circle. I have already filled out up here the ones that you should already have filled out from yesterday. Right now, let's go ahead and fill out, like I said, this is 60 degrees. If I reflect it into the second quadrant, it's going to be this one. Into the third, if I reflect it down, it'll be right there. And if I flop it over to the fourth, it'll be right there. So make sure you're writing it on the right lines as we go so that you're not confused later. And also, I know my poster's up here. I've been debating whether to kind of like take it down because I know it's tempting to just fill everything out right now. But I have kind of bad handwriting anyways, and I've noticed some people have actually thought they wrote down what I had, but they thought it was a 3 and it's actually a 5. And so listen to what I'm saying right now as we roll it out because I don't want you to write down the wrong thing. I know my handwriting's not that great. Sorry. Okay. So notice if I want to know the degrees on all of these, let's roll out 60 degrees because I'm just splitting my triangle up. Take a look up here really quickly. If you ignore the other lines, do you agree that these kind of pizza slices are the same size all the way around? They're all 60 degrees. So let's count 60 degrees at a time. If I have 60 and I go another 60 degrees, I'm at 120 degrees right there. I go another 60 degree pizza slice, 120 plus 60, any takers?
180.
Already got that one, so we don't need to write it, but yes. Okay, take 180, add another 60 degree pizza slice, 240 degrees, I heard Adrian say. Okay. Brandon, coming to you for the next one. 240 plus another 60 degrees, where are we at? 300, write that down. And then let's just check to make sure if I add another 60, I'm at 360, which makes sense because that's a full circle. Okay? Alright, we got all the degrees for 60 all the way around the circle. Radian time. We said that this is pi over 3 because it's a third of that top half, which is pi. Okay, so that's 1 pi over 3. That's 1/3 of that pi. Yep.
So the second one would be 2 pi over 3?
Correct. 2 pi over 3 would be right here, which means 180 degrees would be 3 pi over 3. Isn't math so cool? What's 3 pi over 3?
Do we have to write it on top of it?
No, I'm just showing you because I think it's cool. Isn't that the same thing?
Yeah.
So that makes sense. So we're counting. Nothing's wrong here. It's all the same.
Cancels out.
So then these cancels. It's just pi. But let's use that 2. So this was 3 pi over 3. So this has to be 4 pi over 3. And then last but not least, this is 5 pi over 3. So again, when I'm saying that we're like memorizing this unit circle, again, more than anything, I want you to understand it. So we don't necessarily need to memorize 5 pi over 3 is right over here. It's more like I need to understand how these pieces work, and you could roll out to figure out 5 pi over 3 is there again if you don't have this paper in front of you. Okay? Okay. Last up are points. I've got, yep.
You forgot 360.
Oh. 6 pi over 3, which simplifies to?
2 pi.
So happy. Okay. And here we go. So we've got, what did we say? 1/2 was our distance over, and root 3 over 2 is our distance up, so that's our point. Raise your hand if you can tell me the only thing that will change when we take that point to quadrant 2. Seen some of those same hands, haven't heard from Jose yet? Yep.
There would be a negative in the x.
X is negative because you go back a half, still up root 3 over 2. So negative 1/2 up positive root 3 over 2 on your triangle. Okay, this time, Leslie, coming to you, what's going to be true about the positives and negatives down here in the third quadrant? Both negative, negative 1/2, negative root 3 over 2. And last quadrant, let's see, Cleo, can you tell me positives and negatives for that one? We did that one. Over here. Are we going forward x or backwards x? So that's positive x, and then up or down for y? Down for y. So the only negative is going to be y, because it's forward x is a positive 1/2, and then down negative root 3 over 2. Just like any old point would be in the fourth quadrant. It's going to have a positive x and a negative y. Okay? Alright. Yay, we're so much closer. We only have one more set left. Okay? You're so close. We're got to get to the 30s. So go back to your notes. Let's do the 30-degree triangle, and it's super similar, so it's going to feel the same. And I'm excited because this is going to be my last time to write this unit circle today. And I've written it about a bajillion times, it feels like now. Huh? 5. And yesterday, 5. So I'm ready to be done. Okay. So we've got 30 degrees right here, which, if I think of 180, 6 of these 30 degrees would fit in 180, which means I'm taking pi and splitting it into 6 pieces. Pi over 6. Okay, so now we look at our triangle. Same thing as we've noticed over and over and over. What is the hypotenuse of our triangle? 1. Where'd that little green marker go? There. 1. And this is 30 degrees. Now, the cool thing about this one that's going to save us some time is that if this is 30 degrees, then that leaves for this other angle 60 degrees, and this is actually the same special right triangle, 60, 30, 90, except we just reorient it the other way, and it's a 30, 60, 90. So instead of the hypotenuse being twice the bottom, this time the hypotenuse is twice this side over here, right? And then the bottom is root 3 times the side over here. Okay, so let's come back over here. It's going to be the same math as before. If this is 1, and we know 1 is twice the size of the side over here, then that means, Maritza, do you know what this side would have to be over here? 0.5 or 1/2. Same as earlier. This is going to be 1/2. And then when we multiply it times root 3, same as before, we're going to get root 3 over 2, except that's going to be the bottom now instead of the side. Okay? And so on our coordinate, that means the distance I travel over is root 3 over 2, and so which coordinate is going to be root 3 over 2? Let's go with Tim. Is this root 3 over 2 representing our x or our y? X. So we're going to write it right here. Good job. And then, what? I know, but then you got it. See, don't be scared.
I was just.
Oh, he's not.
I mean,
And then right here, 1/2 is the other side, and so that's going to be your y because it's how much you're going up or down. Okay? So we have the same point, but x and y are switched, which is nice because we don't have a whole new set of numbers to remember, except kind of confusing because it's the same ones just mismatched, and so there's a lot to kind of keep track of here because it's very similar but not the same. Okay, so last time, get excited, grab your yellow unit circle. We're nearly done. You nearly have a masterpiece. Last 4. Dun dun dun. Okay. This guy, this guy, this guy. Oh no.
Oh no.
And this guy, right? You okay, Samantha? Stressed out? Over the unit circle? Everything? Take a deep breath. Look, there's 4 more on the right side. Alright. Here we go. You're so close. How many minutes we got? 13. The grand scheme of things, you can survive through 13 minutes, I promise. No one is going to keel over and not make it. Okay, here we go. 30 degrees. Stick with me, don't let me lose anyone. I haven't lost anyone in my almost 1.5 years of pre-cal yet. Okay, 30 degrees. When I count by 30s, something interesting is going to happen. A lot of them we've actually already done. Hey, you need someone?
Yeah, where's Louise B?
Oh, bye-bye. Make sure you get the 30s. Can you get the 30s?
Or is it?
Okay, you're good.
Did it?
See ya. Okay.
Oh.
I'm so excited. Okay, 30 degrees. Something interesting is going to happen. If I count by 30s, if I add another 30, I'm not all the way going to jump all the way over here to this other green one that I'm trying to find. What's 30 plus another 30 degrees?
60.
It's actually like a lot of these we're going to already have. So we're just going to like leave them because we already wrote them down. So we got 30 plus another 30 would be
90.
90, already got it. Plus another 30 would be,
120.
already got it. So now let's do 120 plus 30, that should get us to the one we need. 120 plus 30, Jose? 150 degrees for this one right here. Stick with me. Watching. 150 plus another 30 is 180. 30 again would be 210. 180 plus 30 is 210. Plus 30 gives me 240. Plus 30 gives me 270. Plus 30 gives me 300. Last one, plus 30 is 330 degrees. Patterns everywhere. And 360. Okay. Radian time. Pi over 6. Any takers in here since I got Luis already figured it out, everyone already figured it out. Without just looking at my poster and taking it, can anyone count by 6s and, or pi over 6 pieces? How many are going to be over here? Leslie? 5 pi over 6. Notice I've got 1, 2, 3, 4, 5 pieces once I get over here, right? But for example, like pick one. 1, 2, 3. If I do 3 pi over 6, that just simplifies to pi over 2. So like we already did those, we're not going to write it as a 6, we're going to write it as a half, right? Okay, so then let's keep going. 5 pieces, 6 pieces, so this is going to be, Carmen, 7 pi over 6, and then let's jump all the way to the last one. Any takers? I heard from Jose already, and Shimei, someone new? I just called any, right? Go again. Why not?
11, 5, and 6.
Okay, nice. Okay.
And don't touch.
And the points. You can do those on your own. I'm gonna write them up here, but we said it's root 3 over 2, 1/2. By now you should have the patterns with the positives and negatives. Go ahead and take like 10 seconds and write them in. This one's gonna be negative x positive 1/2. Okay, about 5 more seconds. Now you're just rolling out the positives and negatives from the one we just did in our notes, okay? Congratulations, you have completed the first unit circle you've ever done in your life. Yes, with 8 minutes to spare. And you can keep this beautiful yellow sheet and frame it and bring it to college. It's going to be your best friend. My teacher in high school, I think, she had a clock that hung in her room, and it's the circle, like behind the ceiling. I've always wanted one, but I don't know if I can. Okay. So, we're down to 7 minutes. Samantha, you can do it. You're still with us, 7 minutes. Carmen, Juan, thank you. Okay. So, for the last 7 minutes, what we're going to do is make sure now that we feel okay with finding sine, cosine, tangent, when the angle's bigger than 360, when it's a reciprocal function, all of those things. But now any angle goes on your unit circle, not just the 45-degree ones that we did in the do first, okay? So, take a look. Start with A, B, and C. C is going to be one of those ones where you have to find a coterminal angle. So it's going to be a little bit harder. Once you've finished those and you've checked with your neighbor and you feel like you got it or you've asked me your questions, then you can move on to the practice below, trying those a little bit more independently, okay? Go ahead, try it out. I'm around to answer questions. Check it. Sorry, you need help?
Ow.
Sorry, son? Yep. There's one there right now. So tangent, if you look back, it's another good thing to write down. So I'm going to write this down. Take one, go your yellow sheet, and then tangent. Always go over. Okay, we got the first two, second and third. Monday, the videos of Monday was, we looked at basically like the one,
And they're like,
And it's a lot.
triangles, and
and it didn't matter. I mean, when we were changing the practice, so we already crossed them down.
They've been crossing the I did. And then like, what's your ex? And I was like,
is where I loud because I want you to practice it.
For example,
How are we doing? Oh no. Aaron. Magnet. Adrian's like, hey, what is happening back here? Don't just waste it. Minutes. Also, these are good.
your answer is going to be, your answer is going to be,
I know, but I know this is
Yeah.
Why pi over 6?
12 pi. 12 pi over 6. Oh, you
And then all this
But instead of taking away, Come on, Justin, where you going? You need to focus. I'm gonna hold you up here. So I need to multiply this Tim, you should be back up. Tim, get your stuff back out. You should be back up. Okay, check them. Alright. Voices down, biceps here. I need everyone, I'm gonna hold y'all, I need everyone to get their papers back out if you packed up, because I got people packing up early that didn't use that time. So take your papers out. I'm gonna hold y'all an extra minute. You'll still make your buses if you have, or if you're a bus rider, okay? Okay. For these first two, I saw people did okay. For the third one, that's one where you need to find a coterminal angle. So you need to change this by subtracting 2 pi. You'll end up getting cosine of 7 pi over 6. And that's one that's on the unit circle that you can find. Okay, one thing I noticed that some people had good questions about that we didn't talk about as much is how would you find something if it says tangent? Does anyone remember what tangent was equal to yesterday? Brenda? Y over x. Stick with me. Y over x. So find 7 pi over 6. Find 7 pi over 6. Yep.
Just do the sine of 7 pi over 6 over cosine of 2.
Because that's y over x. So 7 pi over 6 is right here. So we're going to do negative 1/2 divided by negative root 3 over 2. To divide fractions, keep the first one, flip the second one, and change it to multiplication. So you've just got some extra math to do with tangent. You're doing y over x, okay? Thank you. Make sure you practice these. You guys on your quiz tomorrow, okay? Bye-bye.